You've already built and secured your ADCS environment. Now we'll focus on running it like a professional service. We'll use auditing, monitoring, documentation, and governance to spot misuse early, prevent outages, and keep your PKI aligned with business and compliance needs. You've built a full PKI: foundations, ADCS deployment, templates, enrollment, troubleshooting, and hardening. Now we pivot from one-time setup to ongoing operations. The goal is to keep the environment stable, predictable, and secure over time by treating PKI as a managed service rather than a finished project. Public key infrastructure is all about trust, and trust fades if no one is watching. Auditing tells you who did what, when, and from where, so changes and abuses don't stay invisible. Monitoring focuses on the health of the service: expirations, revocation failures, enrollment errors, and availability. Governance decides who owns what, how approvals work, and how often things are reviewed. Together, these disciplines stop small configuration mistakes from quietly becoming outages or security incidents. CA auditing is your forensic record for the certification authority. It shows who requested certificates, which were issued or denied, when they were revoked, and who changed CA settings. All of this lands in Windows security logs, but only if you enable the right audit categories and size the logs correctly. Treat these logs as sensitive assets. Protect them from tampering, centralize or forward them, and review them regularly, not just after something goes wrong. Think of certificate issuance as account creation for your PKI, and you want full visibility into who gets what and when. Audit every issued certificate by requester, subject, template, serial number, and time. Then flip the view. Failed, pending, and denied requests often reveal attackers probing the system or broken business processes. Pay special attention to high-risk templates and verify that enrollment activity actually matches real workflows and approved owners. Revocation is where certificate control often fails, so treat it as a complete, auditable process. Start with the decision: who requested revocation and why. Confirm the request was properly authorized and mapped to a clear reason code, like key compromise or superseded. Then verify revocation was executed, the CRL or status service updated, and that clients can see the change. Finally, make sure the event is documented and later reviewed during incidents and operational meetings. Configuration changes fall into two buckets: routine maintenance and security-sensitive events. Adjusting CRL intervals or fine-tuning issuance settings is usually normal, as long as it's recorded. But changing template EKUs, subject name rules, or enrollment permissions can quietly expand who can mint powerful certificates. The same risk applies to edits on CA ACLs or enrollment agent rights. Those changes should trigger immediate review, because a single unauthorized modification can undermine your entire PKI trust model. Certificate services are core infrastructure, so manage them like any other critical application. First, confirm the CA service and server are actually up and responding. Next, monitor event logs for errors or frequent restarts that hint at deeper issues. Continuously track disk space, database size, and backup success. A full disk can stop issuance just as effectively as a crash. Finally, feed these signals into alerts, so you know right away when something degrades. Certificate validation usually fails at the client when it can't reach what the certificate points to. Every CRL and AIA URL is a dependency that must stay healthy. Treat these endpoints like critical services. Test them from the same networks your clients use, verify HTTP and file share accessibility, and track CRL expiration closely. You want alerts while everything still appears to work, so you can publish new CRLs or fix endpoints before users ever see broken TLS. Most certificate outages trace back to one root cause: nobody noticed the expiration in time. To avoid that, maintain a single view of every certificate, grouped by how soon it expires and tagged with its owner, system, template, renewal method, and risk level. Focus first on certificates that keep the business running: IIS, VPN, RDP, Wi-Fi, smart card logon, and domain controllers. Then confirm auto-enrollment is working as expected, and use reports to find orphan certificates before they surprise you. Consider a service account that suddenly fires off 80 failed requests for a user authentication template overnight. That's not noise, that's a signal. Your alerting should flag repeated failures from the same account or host, especially when the template can grant logon or VPN access. From there, look for enrollment spikes or activity at unusual hours and correlate with AD changes, template permission edits, and privileged account actions to determine whether you're seeing misconfiguration or active abuse. A practical PKI monitoring model starts by choosing the signals that really matter: CA health, CRL and AIA availability, expirations, enrollment anomalies, backups, and key security changes. Next, you define thresholds, so warnings appear early, but not constantly. Then you route alerts to the teams that can act on them: infrastructure, security operations, IAM, or application owners. Finally, you document response steps, so every alert leads to a predictable, auditable incident workflow. Documentation is your future self's best friend in PKI. Capture the full CA design: who issues what, where the servers live, and which algorithms and key lengths you use. Define each certificate template and its EKUs, who can enroll, and which approvals are required. Record every revocation and validation URL, along with schedules and dependencies. And document backups, restores, renewal plans, and operational runbooks, so anyone can safely operate the system years later. Operational governance turns PKI from a series of one-off fixes into a predictable service. Start by assigning named owners for the CA, templates, monitoring, backups, and key applications, so nothing is everyone's job. Then require that any change follows a defined path: request, risk review, approval, implementation, and monitoring. Regular reviews and simple metrics, like expired certificates and CRL health, show when the system is drifting and needs correction. Everything we've covered comes down to 4 habits: audit what your PKI does, monitor how it behaves, document how it's built, and govern who can change it. Sustainable PKI depends on continuous visibility and control, not one-time projects. In the next module, we'll apply this same operational discipline to Azure and hybrid PKI integration.